Today, I'm excited to take you through an incredible transformation journey, one that took a slow, outdated Postgres data warehouse and turned it into a high performance real time analytics powerhouse on Snowflake. If you have ever worked with legacy systems that just can't keep up with modern data demands, you will definitely relate to this story. The company we work with, a major US delivery services provider, was struggling with frequent data outages, slow processing times, and the inability to scale. Their goal: a modern, automated, and real time data architecture that would empower their business users with instant insights. And that's exactly what we delivered with Snowflake. Let's dive in, starting with the challenges they faced. So, what was the real problem? Why did they need this migration? Well, their existing Postgres based data warehouse was simply not built for scale. Here were the key challenges. First, being high latency. Their data ingestion and processing took hours, sometimes even days. This meant business users were working with outdated reports instead of real time insights. Then, there were frequent data outages. Their system kept crashing under heavy workloads. 90% of the failures were due to system downtime. Then there were a lot of manual interventions. ETL jobs required constant babysitting. Errors meant hours of troubleshooting and slowing down their operations. Also, another key thing was there was no CDC change data capture happening. Every time they needed an update, they had to refresh the entire tables instead of just processing new or changed data. And finally, there was slow third party data integration. Adding new data sources was a nightmare. Each new integration required custom scripts and weeks of effort. Clearly, their architecture was holding them back. Now let's look at what their system looked like before the migration. So their existing architecture had serious limitations. Let me kind of walk you through it. So the company relied on 20 plus different applications in-house RDBMS systems, but their ingestion was outdated, leading to longer delays. The ETL processing was in Postgres. So Postgres was not designed for high-speed, large-scale ETL workloads. The lack of real-time streaming meant batch processes frequently failed, further increasing the latency. And it also meant high maintenance costs. So running on-prem infrastructure meant huge operational costs. Teams were spending too much fixing failures rather than focusing on business insights. So as you can see, this architecture was monolithic. You had multiple data sources, and the data warehouse was on Postgres. Most of the ETL was done on Postgres, and this architecture was on-prem, and it was monolithic and inefficient. So this caused multiple operational as well as scalability issues. So clearly they needed a radical change. So we designed a future-proof cloud-native architecture that solved all these problems. So enter Snowflake, the fully automated, scalable, and high-performance data warehouse that transformed their analytics landscape. Let me walk you through the key components of the new architecture. As you can see from the diagram, so we implemented Fivetran to extract data from Postgres and move it to Amazon S3. This eliminated manual ingestion headaches. We used Kafka and AWS SNS to stream real-time events, enabling instant data movement. To handle third-party data sources, we integrated Segment API and custom connectors to ensure seamless data flow. And then we had automated processing in Snowflake. So once the data landed in S3, Snowpipe automatically picked it up and loaded it into Snowflake. No more waiting for batch processes. Business logic and transformations were handled natively within Snowflake, reducing complexity and improving performance. Then, for real time data streaming and change data capture, one of the biggest upgrades that was implemented was on the CDC aspect for this customer. So this was done using Kafka. This allowed us to process only modified records instead of refreshing full tables, making the systems faster and more efficient. And also, we kind of structured and processed the data into data marts, making it easily accessible for BI and data science teams, business users could now generate real-time dashboards in seconds. So this was how the future state architecture looked like. Now let's talk about how we made this migration happen. So migration of this scale required careful planning and execution. Here's how we did it. The first step was assessment and planning. We conducted a full audit of the existing system to identify dependencies and risks. We defined data governance policies to ensure data consistency. In the next step, we kind of figured out the incremental migration strategy. So we used Fivetran to replicate data from Postgres to S3. We implemented Kafka CDC to track real-time changes. And then on validation and testing, we compared the migrated data against legacy Postgres data to ensure data accuracy. And here, as part of automations, we developed automated scripts for data validation and consistency checks. And finally, in the last step, we decided on the final cutover and go live dates. So we switched to the Snowflake as the primary data warehouse here, and we kind of implemented automated monitoring and alerting for proactive issue resolution. And now for the big question, what impact this migration had for this customer? So the results were outstanding. Let's go over the key improvements. First being near real-time data availability. Data that previously took hours to refresh is now available in seconds or minutes. It led to 90% reduction in data outages. Automated ingestion and Snowflake's failure mechanisms virtually eliminated the data failures. We also implemented seamless change data capture. CDC processes now processes only the changes instead of the full table refreshes, cutting down processing time significantly. We also built fully automated and low maintenance pipelines. So Snowflake plus Fivetran plus Kafka reduce operational overhead. So there was no more need for manual interventions. This architecture also supported faster third-party data onboarding. New data sources now can be integrated in days instead of weeks. And finally, it also led to significant cost savings. With Snowflake's auto-scaling, the company optimized storage and compute costs while gaining infinite scalability. This migration didn't just improve their operations, it transformed their entire approach.